Hello and welcome to the video notes for Lesson 6.2, Properties of Parallelograms. This video might work a little bit differently. I'm really going to try and streamline the content I give you as far as conserving some time. And so I won't spend as much time explaining all of the vocabulary pieces. I will show them to you and we'll talk briefly about them, but we're going to spend most of our time focusing on the examples. So if you have not completed the vocab, or if you are confused about any of the vocabulary, please use your textbook, your online textbook, or your vocab notebook to review any of that material. Make sure you have done the vocabulary in your notes and your vocabulary notebook. And make sure you've also done this warm-up that you see on the screen. If you haven't, go ahead and pause the video, do that now, and then we will check our answers in just a few seconds. So again, pause the video if you need more time. Alright, here are the answers we should get. For x, since these angles 29x and 61x are same side interior angles, they're supplementary. If you solve an equation, set these two, add these two together, set them equal to 180, x is 2. These two are alternate interior angles, which are congruent. So if I set these two values equal to each other and solve, y is 4. And lastly over here, you might remember that the two acute angles of a right triangle are complementary, so if I take 72 away from 90, z is 18. Alright, let's go ahead and begin the lesson. Here are your objectives. We're going to prove and apply properties of parallelograms and use properties of parallelograms to solve problems. The only vocabulary term you have is parallelogram, but we will be reminding you of several other things, so there's some blanks you should fill out as we begin this lesson. Any polygon with 4 sides is called a quadrilateral. However, some quadrilaterals have special properties. These special quadrilaterals are given their own names. A parallelogram is a quadrilateral with 2 pairs of parallel sides. We will use this symbol to name that parallelogram. So it might look like this. If you're given this parallelogram that you see in your note packet, we would call it a parallelogram ABCD, and we would use this symbol to name it. You'll notice the opposite sides are parallel. Make sure you have all of this information written in your note packet. And then you will also notice next there are 4 theorems we're going to look at. These theorems talk about the properties of parallelograms. Something I want to point out on each one of these, in parentheses, you will notice the notation that is supposed to be used when working with these in a proof. And you'll notice that they also start off with given that you have a parallelogram. So the properties I want us to focus on are as follows. Parallelograms have opposite sides that are congruent. Parallelograms have opposite angles that are congruent. Parallelograms have consecutive angles that are supplementary. And parallelograms have diagonals that are congruent. So to recap those 4 main properties, in a parallelogram, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. This one is the only one that talks about diagonals. So let's try and put some of these properties into practice and do some problem solving. In example 1a, we are given several pieces of information about this parallelogram to use on example 1a, b, and c. And so let's take a look. First, on example 1a, we are told to find CF. Well, we're going to recognize that CF is an opposite side from DE. They give you the measurement for DE. Remember, in parallelograms, opposite sides are congruent. CF is congruent to DE. And by definition of congruent segments, that means their lengths are equal, so we can substitute 74 for DE, because that is what we are given. That information is given to you. So we can substitute 74 for DE. And CF then would have to also equal 74 millimeters. On part B, we are looking for the measure of angle EFC. EFC. And we're going to look at the given information that FCD is 42 degrees. Well, FCD and EFC are consecutive angles. In a parallelogram, consecutive angles are supplementary, so their measures should add up to 180. So if I substitute 42 in for FCD, and I subtract 42 from both sides, the measure of EFC is 138 degrees. Again, these two add up to 180, so I take 42 away from 180 to get 138 for EFC. In example 1C, we're asked to find DF. DF is one of the diagonals. Well, the only other given information about the diagonal is that DG is 31 millimeters. But remember, the diagonals bisect each other. That makes G the midpoint of DF. Since in a parallelogram diagonals bisect each other, DF is 2 times DG. G is the midpoint. So I can substitute 31 for DG and multiply it by 2, or double that length, and get that DF is 62. Alright, in example 2, we're going to do a lot more of the same kind of work, but we are going to use the algebraic expressions. We are given in example 2, A and B, that this is a parallelogram. In this parallelogram, we have these opposite sides and these consecutive angles. So in order to find YZ, we're going to use the fact that in a parallelogram, opposite sides are congruent. So YZ and XW are congruent. So their lengths are equal by definition of congruent segments. And if I substitute those values in, I get this equation. This equation would allow me to solve for A. Once I know A, I can plug it back in and find the length of YZ. I'm going to give you a moment or two, pause the video. I want you to try and find A and plug it back in and tell me what YZ is. Alright, if you are ready, this is what we should get as an answer. We should get A equals 7, and if I plug that back in, YZ and XW should both equal 52. 8 times 7 minus 4 is 52. On part B, you're asked to find the measure of angle Z. Well, the measure of angle Z and the measure of angle W should add up to 180 degrees because in a parallelogram, consecutive angles are supplementary. So if I substitute those values in, I get this equation. If I can solve this equation for B and plug B back in for the measure of angle Z, 9B plus 2, I should be able to get that angle measure. Why don't you take a few minutes, pause the video to work this out, and then we will check our answers together. Alright, if you have had enough time, go ahead and take a look at what we should get. We should get that B is 7 when you combine like terms and solve for B. If I plug that back in, the measure of angle Z, 9B plus 2, becomes 9 times 7 plus 2, which is 63 plus 2, or 65 degrees. If you wanted to check that, you could plug 9 in here, and you should get the supplement of 65 degrees, 115 degrees. In examples C and D of example 2, we are using the diagonals. The key part or key property of parallelograms regarding diagonals is that the diagonals bisect each other. So to find JG, we're using the diagonal EG. J would be the midpoint. So we need to remember that in a parallelogram, diagonals bisect each other. That means that JG is half of EG, or that EJ and JG are congruent. I can substitute the values for EJ and JG, 3W and W plus 8, and solve for W. If I divide both sides by 2, W is 4. But that's not the final answer. You are asked to find JG. So I'm going to take that 4 and add it to 8, and I get that JG is 12. Why don't you take a few moments, use that same kind of concept to find FH. Pay attention to the fact that what you're supposed to find is the entire diagonal FH. Pause the video if you need more time. Alright, let's check out our results. Since the diagonals bisect each other, FJ and JH are equal, And by substitution, these two expressions are equal, and if I solve that, z is 4.5. If I can plug 4.5 in for z in both of these expressions, then add them together, I get that FH is 18. Remember, when you're drawing a figure in the coordinate plane, the name ABCD gives the order of the vertices. The reason this is important is because we're going to be working on a couple examples now using the coordinate plane and parallelograms within the coordinate plane, and the order of those letters gives you the order of the vertices. So in example 3a, we're going to take a look at the coordinate plane, and we're going to talk about parallelogram JKLM. We are given three of the vertices, J, K, and L. We need to find the coordinates of the fourth vertex, M. The first step is always to plot the given points. Now, since JKLM is a parallelogram, remember both pairs of opposite sides must be parallel by definition. So I'm graphing the given points, J, K, L, and I have to find M. Now notice the order, J, K, L, M. That means M must be somewhere to the right and between J and L. So M is going to be somewhere over here. So the next step is to talk about the slope of one of the sides that I can clearly see, like KL. So we're going to talk about the slope of KL. We'll use rise over run. The rise from -2 to 6, or from 2 to 6, I'm sorry, is 4, rising 4. The run is also 4 from -2 to +2. So the rise over run from K to L is up 4 to the right 4. We can follow that same pattern from J. By starting at J, we can rise from 4, or rise 4 from -8, and run 4 over to 7 here. That gives you the coordinates 7, -4 as the vertex of M. And we would see that creates this parallelogram. In order to verify that, remember the other pair of opposite sides must be parallel, so they should also have the same slope. So I will verify that using the slope formula. The slope of LM, the rise is -4 for M, -6 for L, which is -10. The run is 7 for M, -2 for L, which is 5. -10 over 5 is -2. KJ should have the same slope. -8 minus 2 is -10. 3 minus -2 is the same as 3 plus 2, which is 5. -10 over 5 is also -2. So this is a parallelogram. That means the coordinates of M are 7, -4. Why don't you take a few minutes to see if you can follow that same process to find the fourth vertex R of parallelogram PQRS. Again, remember both pairs of opposite sides must be parallel, and the first step is to graph the given points. PQR would come before getting to S, so that should tell you R must be somewhere above S and to the right of Q in this area right here. So we're going to use the slope of PQ, duplicate that from S to find R. Pause the video if you need more time, otherwise we will go ahead and check out our results. From P to Q is a rise of 6, a run of 2, so I'm going to duplicate that from S. Rise 6, run 2. That gives me the coordinates 7, 6 for the vertex of R. And in order to verify, you would only need to check the slope of QR and PS. From Q to R, we would rise 2, run 1, 2, 3, 4, 5, 6, 7, 8. So that's a rise of 2, run of 8. That's a slope of 1/4. We would have the same slope, rising 2, running 8. Over 2 over 8 is 1/4 for PS. All right. This hopefully should make things a little more clearly. We will begin the assignment for 6-2 in class, but I have attached it to the post as well. Good luck.